Hey everyone, today I am going to explain the rules and formulas of differentiation. But before we dive into the math, we need to be clear on a few things. What is differentiation? Where is it used? And how is it applied in real life situations? Differentiation is the study of how fast something is changing at a specific moment. It allows us to find the rate of change accurately even when the changes are incredibly small. Think about your kitchen. Cooking is full of rates of change, which is exactly what differentiation is all about. Take a cold stick of butter in a hot pan. It doesn't disappear instantly. It melts at a specific rate. As the pan gets hotter, that melting rate changes. If you wanted to know exactly how fast it's disappearing at the 5-second mark, you would need calculus. To see how this works mathematically, let's look at this curved line y equal to x square. Right now, we have a straight line balancing perfectly on the curve at just one single point. In calculus, we call this a tangent line. The steepness of this line tells us our exact speed at that exact moment. But watch what happens. When we start dragging this point along the curve, as it moves, the balancing line tilts and changes direction. When we drag the point all the way down to the very bottom of the curve, the line goes completely flat. A flat line means there is no steepness at all. So, for a split second, the speed drops to 0 and everything stands perfectly still. But as we drag the point back up the right side, the line tilts higher and higher. It gets steeper and steeper, which means our speed is absolutely exploding upward. So, instead of standing in the kitchen watching butter melt with a stopwatch or manually dragging a line on a graph forever just to find the speed at every single spot, mathematicians found a better way. They discovered brilliant shortcuts that let us calculate these exact speeds instantly. Let's get started with the rules and formulas. Let's get started with the power rule. The power rule says d by dx of x to the power of n equal to n times of x to the power of n minus 1. This means we bring the power down to the front and subtract 1 from the exponent. For example, suppose we have d by dx of x to the power of 5. Here we have replaced n by 5. So bring the 5 down to the front. Then subtract 1 from the exponent, that is 5 times of x to the power of 5 minus 1, which gives us 5 times x to the power of 4. Constant rule. Now look at the constant rule. The constant rule says d by dx of c equal to 0. A constant does not change, so its derivative is always 0. For example, d by dx of 7 equal to 0. So 7 is just a constant, so the answer is 0. The constant multiple rule. This rule says that d by dx of c times f of x equal to c times d by dx of f of x. This means we keep the constant outside and differentiate normally. For example, d by dx of 5x cube, keep the 5 outside. Then differentiate x cube normally, which is bring the 3 down and subtract 1 from the exponent. So 3 times of x square. Therefore, 5 times 3 is 15. 15 x square. So d by dx of 5x cube is 15x square. Let's learn the sum and difference rule. This rule says d by dx of f of x plus or minus g of x equal to f dash of x plus or minus g dash of x. This means we differentiate each term separately. F dash g dash is nothing but the derivative of f of x and g of x. For example, we have d by dx of x to the power of 4 plus 3x square minus 7. Differentiate x to the power of 4, which is 4x cube. Then differentiate 3x square, which is 6x, and the constant becomes 0. So the answer is 4x cube plus 6x. Product rule. This rule says d by dx of f of x gx equal to f dash of x into g of x plus f of x into g dash of x. This means derivative of the first term times the second term plus the first term times derivative of the second term. We use this rule when two functions are multiplied together. For example, we have d by dx of x square into x plus 1. So, derivative of x square is 2x. And keep x plus 1 the same. So, then derivative of x plus 1 is 1. And keep x square the same, which is x square into 1. So the answer is 2x times of x plus 1 plus x square. Quotient rule. We use this rule when one function is divided by another. The quotient rule says d by dx of f of x divided by g of x equal to derivative of the numerator, that is f dash of x, times the denominator, that is g of x, minus numerator times f of x, derivative of the denominator, that is g dash of x, all over the denominator squared. For example, suppose we have d by dx of x square divided by x plus 1. First differentiate the top term and keep the bottom term the same, that is derivative of x square is 2x. So we get 2x times of x plus 1. Next keep the top term the same and differentiate the bottom term, that is derivative of x plus 1 is 1. So we get x square into 1. Now subtract them and divide everything by the bottom square. So the final answer is 2x times of x plus 1 minus x square divided by x plus 1 the whole square. Let's learn the exponential rule. This rule says d by dx of e to the power of x equal to e to the power of x. This means the derivative of e to the power of x is simply itself. I will explain separately in the next video why the derivative of e to the power of x stays the same using a real life example. Finally, let's look at the general power rule. This rule says d by dx of u of x the whole power of n equal to, first differentiate the outside power, that is n times u of x the whole power of n minus 1, then multiplied by the derivative of the inside, that is u dash of x. For example, we have d by dx of 3x square plus 1 the whole power of 4. Bring the 4 down. Subtract 1 from the exponent, that is 3x square plus 1 the whole cube. Then multiplied by the derivative of the inside, that is derivative of 3x square is 6x. So those are the basic rules and formulas of differential calculus. Thanks for watching and I'll see you in the next video.